Good day everyone, here is our presentation for our weekly group task and we are group 2 from grade 11 Bernoulli. Riemann sums refers to the number equal to the combined areas of the rectangles are drawn under the curve towards the x-axis. There are three possible ways of drawing rectangles. Number 1. Left Riemann sums. The upper left corner of the rectangles intersects the curve. Number 2. Right Riemann sums. The upper right corner of the rectangles intersects the curve. And lastly, number 3, midpoint Riemann sums. The midpoint of the upper edge of the rectangles intersects the curve.
So starting off with the left Riemann sums, we have a function f of x is equal to x cubed minus x squared minus x plus 2. So with the use of GeoGebra, it will be visualized into this format. So with this, we used rectangle sum to find the area connected to the upper left of the n, in which n represents the 8 rectangles. So also a and b is from 0 and 2. So in which again will look like this. So now solving for the area with the concept of left Riemann sums, we need to use the partition points to determine the values of x and y, because actually the concept of finding the area is just like the length and width of a rectangle. So also we need to know the step size, which is 1/4. So with these values, we can now use the formula given, which is summation of f times x sub k minus 1 multiplied to the delta x, in which k is equal to 1 until the value of n, which is actually 8. So with a lot of calculations and input from x sub 0 to x sub 7, therefore, the area under the curve of f of x equal to x cubed minus x squared minus x plus 2, considering 8 rectangles at 0, 2, is approximately 3.125 units.
Okay, so before proceeding to the main part, with the use of GeoGebra and utilizing the command integral, we input the given to show the visual representation of the function and to also find the definite integral. It will look like this. And as you can see, we use the rectangle sum for the values of the given function x cubed minus x squared minus x plus 2, a and b, which are 0 and 2, and n, which is 8. So to start off with the solution, we have these partition points, which will be used later when solving. For now, we will determine n, which is the number of rectangles. So in this case, we have the value of 8. And then we need to find the step size, which is 1/4. After that, we will now be using the partition points. To get the sum of the areas, we will be using the formula of the right Riemann sums, which evolve from the formula of the left Riemann sums. The only difference is that 1 is not subtracted in the formula, since we will be using the last partition point for the height. After solving everything, the area of the curve of fx is equal to x cubed minus x squared minus x plus 2, considering 8 rectangles at 0, 2 is approximately 3.625 or 3.63 units.
We will use midpoint Riemann sums to get the area under the curve of our function f of x is equal to x cubed minus x squared minus x plus 2. The first thing we need to do is to get the midpoints. So we will use partition points to identify our midpoints. And the partition points we're going to use are 0, 1/4, 1/2, 3/4, 1, 5/4, 3/2, 7/4, and 2. So let me give you one example on how to solve for a midpoint. Let's try to solve for m sub 1. To get m sub 1, we just need to add x sub 1 and x sub 2, then divide it all over by 2. And after doing that, we now have m sub 1, which is 1/8. So basically, that's a pattern that we will use to solve for our midpoints. And the midpoints for our example right here are 1/8, 3/8, 5/8, 7/8, 9/8, 11/8, 13/8, and 15/8. And we should always remember that the number of midpoints should always be equal to n. Since we have found the midpoints, we can now get the sum of the areas. To get the sum of the areas, we just need to evolve the formula for the right Riemann sums. We will change r sub 1 to m sub 1, and we will also need to replace x sub k with m sub k because we will be utilizing the midpoints instead of the partition. After getting the summation of the areas, we now have our answer, which is m sub 1 is equal to 3.3125. Therefore, we can say that the approximated area under the curve of f of x is equal to x cubed minus x squared minus x plus 2, considering 8 rectangles at 0, 2, is approximately 3.3125 units.
We will use the fundamental theorem of calculus to find the definite integral of the function f of x is equals to x cubed minus x squared minus x plus 2 at 0 and 2 and n is equals to 8. First, get its antiderivative, x cubed minus x squared minus x plus 2 dx. It'll be f is equals to x raised to 4 over 4 minus x raised to 3 over 3 minus x squared over 2 plus 2x. Then, substitute it to the formula where a is equals to 0 and b is equals to 2, f times b minus f times a. It'll be 2 raised to 4 over 4 minus 2 cubed over 3 minus 2 squared over 2 plus 2 times 2 minus 0 raised to 4 over 4 minus 0 cubed over 3 minus 0 squared over 2 plus 2 times 0. It'll be 10 over 3 minus 0, and the answer is 10 over 3 or 3.33.
The answer that we get using the fundamental theorem of calculus is approximately the same with the midpoint Riemann sums answer, but the answer that we get when we use the right Riemann sums is higher than the FTOC. And last, when we use the left Riemann sums, the answer is lower than the FTOC.
That wraps up our video for this week. We hope you learned and enjoyed something new in our presentation. Thank you and see you next week.